Hi, Mrs. Eva's back, and this is part 2 of the video. Go ahead, and if you are in period 2, please write the secret code. Here's the secret code. Secret code for period 2, peaches. If you're in period 3, your secret code is bananas. Oops, I forgot period 1. I don't know why. Period 1, our secret code is strawberries. And period 5, your secret code is apples. Okay, you're going to write this right here on this page, right next to problem letter A. And as I was going quickly through problem 2 here, we picked out 3 coordinates that happen to cross our graph, and these coordinates represent the time that they drew the portrait and the number of portraits that were drawn. So we had this was the number of portraits, and then T was the time. So we've got my X on our horizontal axis and the Y on the vertical. So we have 2 hours. X gives us 3 portraits, Y, and that's what we see in these parentheses with the comma, separated by a comma. 4, 6 means there was 4 hours spent, which is this coordinate right here, and 6 portraits that were produced. And here we have 6 hours spent and 9 portraits produced. Now, of course, we can definitely have points here, here, here. However, you know, we'd have to guess if it's happening at like the 5.5 hour mark. We don't know. It could be 5.25. It could be 5 and a little less than a half. So it's good to find points where there's whole numbers, right where the grids cross each other. Now we're going to write an equation that represents that. Now, because each of these ordered pairs can create a constant of proportionality, that's going to help us find our equations. Now, the constant of proportionality is always our letter K, and our K is actually always equal to Y over X. It's going to be the Y-axis over the X-axis. So usually if we have like gallons and miles, then we have miles per gallon. If we have the time and the number of portraits, then we have number of portraits over time. Our output over the input, and our input. So here, our constant, we're going to use each of these 3 separate coordinates to create 3 different K's. So I'm going to label K, the first point, as K1, and I'm going to say the constant is Y over X is 3 over 2. And our second constant, constant 2, is going to be again Y over X, and here is going to be 6 over 4, that second coordinate. And then the third coordinate is going to give us K3, which is going to be Y over X equals 9 over 6. Now this is purely just our K's. We're going to take those K's, let me highlight that, and we're going to write 3 separate equations. Those 3 separate equations are all going to fit in the equation Y equals Kx, Y equals Kx, Y equals Kx. Now there's different K's, so here this is the first K, this is the second K, and this is the third K. So our first equation for, and I'm still on B, this is all B right here, is going to be Y equals 3 over 2 X. That's our first equation. Our second equation is going to be Y equals, and our K is 6 over 4, so 6 over 4X. That's our second equation. Our third equation is going to be Y equals 9 over 6 is our K, times X. That's our third equation. Now actually all 3 of these equations are the same. The ratio is just different. The constant is all the same. If I were to reduce 6/4, I would get 3 over 2. If I reduce 9/6, it's 3 over 2. This is the equation right here that determines the unit rate and everything. Well, now I'm going to talk about C. Well, I just talked about the constant of proportionality because I needed it to find my equation. So here, I've already explained the constant of proportionality because I did B. And go ahead and explain what the constant of proportionality means. Remember that since it represents y over x, go ahead and just relate that back to the y, what it says right there. I'm not going to say it for you. And then what it says in the x, it is the number of portraits per hour spent. Perfect. Just to translate this fractional for us, this constant of proportionality as 3 over 2, it's really the same as 1.5 or 1.5 as a mixed fraction and as a decimal. So 1.5 portraits are produced per hour. That is what our constant of proportionality actually means. I hope that was helpful. We're going to move on to the homework. So here is your homework assignment. I will help you with number 1, but you need to do the rest by yourself. If you need extra space on the worksheet, please use a separate sheet of paper to help you. Okay, we will complete the rest of it in class tomorrow as well. So please do not freak out if you don't get it. All right, number 1. We've got 3 cans and 9 tennis balls. So we're considering the number of balls per can. If I drew a picture, sometimes that really helps. If I draw 3 cans and there's 9 total cans, then I can see that each can will contain how many balls? So the constant of proportionality is the 9 balls divided by the 3 cans, which means that there's 3 balls per can. Okay, that's our constant. And our equation, since this is our k is 3, then our equation is going to be y equals kx. Our k is the 3, so if we plug that in, y is equal to 3x. Now, what do the separate x's and y's represent? My x is going to represent the number of cans, and the y is going to represent the number of balls. That's why you will see when I wrote this equation here, 9 over 3, it was y over x. Y is the number of balls and x is the number of cans. I want to know how many balls per can. Y is the balls, x is the cans. I hope all of this is kind of tying back together. Try the best that you can. I hope to see you tomorrow, and don't forget we had a secret code. I'm going to go right back to that, and that's going to determine your points that you actually watched the video. This is what the secret code is for each separate period. See you tomorrow. Bye.